Alright, so this is the DC motor tachymeter. You can see here I have my MOSFET, and here I have the infrared receiver and emitter, which are going to track the hole that rotates around this DC motor shaft. As you can see, when this slit passes through this channel of sorts, the IR light jumps the gap from the receiver to the emitter, and a low is produced, and that falling edge is captured on the interrupt. So unfortunately my MOSFET isn't working. It became broken, and as you can see here, here's my potentiometer, which would control the PWM pin if the MOSFET was working. But I still have this rigged up, and it still can count the RPMs of the motor, so I'm just using a separate battery here to demonstrate the tachymeter. So what we'll do is we'll turn this motor on, and then I'll let you guys see the serial monitor. Alright, so we have our spinning motor here, and let's place it right in front of that IR emitter, making sure not to scrape the plastic. Alright, so now you're going to see the serial monitors reading about 4,500 RPM, and that's due to the fact that this doesn't have access to that PWM signal, so the motor can't produce as high of an RPM. Also, I had to do a little bit of a solder touch-up on the motor because the leads broke, but you can still, it's a pretty consistent reading. Yeah, it's almost exactly 4,500 RPM. Alright, so now let's turn the motor down. Maybe we'll see the RPM go down. Alright, and there it is, it's back to 0.